All right, thank you, thank you. So my name is Daniel Krook. I'm a senior software engineer in the IBM Cloud organization. So today I'm going to talk about serverless architectures, event-driven programming, and a new open source project called OpenWhisk that supports those type of cloud-native applications. Okay, so my goals here to really help you understand this emerging model and position it in terms of what we've seen in cloud computing to help developers create applications faster, better, and cheaper than they have before. And then I'll go into how OpenWhisk helps that happen, what the programming experience looks like, and how to get involved, what it can integrate with, and move forward from there. So has anybody here heard of OpenWhisk yet? Okay. And has anybody had a chance to use it on the hosted environment on Bluemix? Okay, got a couple people. I expected that. I hoped that for that, actually. Okay, great. Okay, so to kind of set the stage for this, what is it about serverless computing that's just so compelling and why it's grown so explosively in the last 18 months? The goal of developers has always been to get the brand new value that they're creating out and deployed to production as quickly as possible. So 10 years ago, if you remember from Dan's presentation, the keynote, to get from point A to point B, you had to go through an operations layer to provision hardware, deal with the configuration, do the capacity planning before you even got to the point where you ordered the hardware. And 10 years ago, we saw the first Amazon services come out, so moving us from bare metal up to virtual machines. And more recently, we've seen what really has been the trends that have created cloud-native computing, which is the container technology deployed as microservices in order to close that gap even further between writing the code and getting it in production. And new serverless architectures really are just an evolution of that, right? They're addressing the same goal, which is to get code from the developer to production as quickly as possible. So that allows them to focus even more purely on the code that's running and less about the operational concerns of making it stay up or making sure it survives huge spikes in load, things like that. And the corollary to that is that they're losing more control over the platform for better or for worse, right? They're ceding control in order to get more control over delivering that business value. And as we've seen cloud evolve and lots more adoption of cloud, there's many more new types of workloads, emerging workloads, that are looking for an event-driven architecture. It's no longer just HTTP REST APIs for microservices that are being deployed to the cloud. There's all sorts of different analytics applications, things that need to be triggered by changes in data. A new order comes into a database, some new action needs to be taken on that. You've got the Internet of Things, where there's lots and lots of new devices being attached to the networks, and those are emitting lots of data. And there's traditional batch jobs. There's still analytics jobs that are moving more and more to the cloud. So you need to have still that scheduled type of action where it's run maybe off hours or at night, but you're still needing some sort of cloud platform to help you do that and scale up as that workload does its processing for maybe the hour and then just goes away the 23 other hours. And of course, mobile applications are growing as well, and these require scalable backends. We did a customer POC with the video gaming company, EA, FireMonkeys, Angel that mentioned it in the keynote, where when they deploy an application, they know the curve of the adoption and when it's going to tail off 10 days later. They just don't know the magnitude of that. It could be 1,000 users, could be 1 million users. So there's these new types of workloads that are being brought to the cloud that need cloud infrastructure. And as people are learning, even as they adopt cloud-native applications, there's still that gap of what happens when you move it from working on a developer workstation out to production, right? So there's a common diagram that's been shown Docker in development, Docker in production, where your only concern is the Docker runtime on your developer laptop. But once you work your way into production, you need to start thinking about when you deploy those containers, how you break down those services, how you make them highly available, and how you distribute them. There's a whole other set of concerns that come with those cloud-native applications. So that can increase the cost to deploy applications, and of course, make things a little harder to manage. Of course, solutions like Kubernetes are designed to address these problems, but there's always some question when you're moving to production how best to do that. The other compelling thing, technical trend around serverless architectures is cloud-native and microservices, you've probably been told over and over again, should be designed in such a way that they meet 12 factors for cloud-native applications. And many of these, it's difficult to address these as the developer that just wants to push code to production. So what a serverless architecture can do is that if you look at those 12 factors, the serverless platform can handle most, if not many, if not most, of the operational related concerns. So the developer is still focused on the code base and its dependencies in many ways, but configuration, discovering other services, doing the build release process, designing on a stateless model around processes, port binding concurrency, and the life cycle of those applications can now be handled by a serverless fabric. There's still, of course, development parity, production, that there's a bit of a life cycle around the code that's naturally going to be in the domain of the developer. Another reason the serverless becomes compelling is that the models of traditional cloud computing, where things are always on, may not be the right match for those particular workloads that only run occasionally during the day and may only run in response to certain events. So there's a mismatch between some of the cloud models for particular types of applications that an event-driven programming model can address. And by matching a cost model better to that, where the application is only billed for the specific time that it's running in terms of milliseconds, rather than by the gigabyte hour of memory reserved, you can get a greater linkage between what your code is doing and what you're paying for. So it makes a closer match. And of course, serverless isn't a magic bullet for all sorts of applications. There's always going to be a need for platform as a service, infrastructure as a service, and any other type of service. But this may be a better match for those emerging event-driven workloads. OK, so taking all those technical trends, those capabilities that are emerging, these new types of workloads that are now ready to be run on the cloud, and combine that with a compelling cost model. And this is why serverless is becoming so popular, and there are so many new options emerging almost daily in terms of hosted services or frameworks to help you take advantage of them. And so that, of course, is something that IBM is very interested in doing as well. So we released an open source project. We announced it about 6 months ago, named OpenWhisk. And in a nutshell, it provides that platform that lets you take advantage of a serverless architecture by hosting code that can execute in response to events. And people who have been playing around with some of the existing hosted providers like Amazon Lambda, you should be familiar with the same type of model, writing code, connecting it to triggers, and executing logic, and so forth. How OpenWhisk is different from that is that it's naturally built as an open source project to be polyglot. So it's got built-in support for not only JavaScript, but Java, Python, the Swift programming language, and obviously JavaScript itself. But it's built in such a way that it can be extensible, which I'll get to in a few other slides. And of course, it's open source with an open ecosystem of partners getting involved. And it's also something that you can not only rely on something like Bluemix, a hosted provider, to run for you, but you can, if you want, explore it. If you're a business partner or another cloud provider, to take it and run it in a public environment, or in some sort of mixed model where some logic may reside internally inside of a firewall and other services can be bursted out to a provider. Okay, and again, there's more and more workloads that are fitting this event-based model. There's a couple of use cases I've got at the booth that I can show. But mobile backends, right? So building the automatically scaling backends as games and apps become popular. Creating, standing up in a DevOps pipeline where code is checked into a repo. GitHub can fire off an event that compiles that application and gives you a resulting good or a bad output. And of course, there's big data analytics, also event-driven. And finally, microservices, right? Traditional microservice. HTTP-backed REST microservices. Okay, so let's take a look into how OpenWhisk comes together, the primitives that drive its architecture. So there's 3 letters. If you remember anything about OpenWhisk, it's these 3 primitives that you're working with as the developer. Data sources are the sources of your events. Those are called triggers. And those are matched to actions or functions which run inside of the OpenWhisk runtime. And the declarative mapping that allows you to associate a trigger to one or more actions or an action to one or more triggers is called a rule. And these things all are packaged, put into units called packages for reuse. So triggers can be any type of event. It can be a webhook from Git. You can have a device reading coming from an IoT device over MQTT or HTTP. User input. So if someone is just creating data in a social network, any sort of hashtags or things like that can kick off a notification. And as things are tracked or users go through virtual reality, I don't want to be the guy that says Pokemon Go like everybody else, but you take an application like that where there's triggered events that can also be used. And the developer focuses on the action that what you want to do based on the data that comes from those events. So you're writing an event handler in response to those triggers. And because OpenWhisk is polyglot, you can write in 4 supported languages, and all you need to do in your action is simply implement basically one function signature. Here in JavaScript, it's just a main function and accept a params object, and you can work with the data that comes in there, and you return out. You can return optionally, run asynchronously, but you can return data in a sequence to another action down the line as well. So besides those built-in runtimes for Java, JavaScript, Node, and the Swift programming language, something that's very unique to OpenWhisk is that you can also, if none of those support what you want to do, if you want to write actions in Go, if you want to write them in PHP or any other language, the open source OpenWhisk can be extended to provide those runtimes, or you can just bring a Docker container to OpenWhisk. And as long as you implement a similar signature, OpenWhisk will inject the events into your code and allow you to participate in an action sequence in a polyglot manner if you need to. And those actions, again, a very extensible model of being able to chain these together to produce different logic and to further help you enforce a microservices design where you have lots of little pieces of code doing independent actions that can be reused, that can be relied upon by other actions. And then the rule that ties it all together. So you can map many triggers to one action from different data sources. For example, you might want to have one action reply to something that happened in GitHub and Slack. Or you might have an action like a notification service that can be called from different triggers, and they in turn can be called different actions as well. Okay, and the package is this construct supported by OpenWhisk to bundle those triggers, those actions, and the rules together. Well, the triggers and actions mostly. And the instance of OpenWhisk that is running in the IBM cloud, the Bluemix cloud, it's already got a bunch of pre-built packages specific to things that we have there, such as Watson. But the open source version also has packages for CouchDB, which can also be run in a hosted cloud environment. So there's some pre-provided packages there as well. There's third-party packages for connecting to, for example, Kafka, grab messages off there. There's the Git package provided for webhooks. And then you have the ability as a developer to assemble your own package of feeds and actions and publish those to the world for people to use. So they can reuse your code either within your own organization or provide those open source yourself to develop an ecosystem around this. OK, so with those concepts in mind, let's see how this comes together. The OpenWhisk execution model, it starts with an event being driven into the system. Those triggers have been associated to an action by a rule. So the OpenWhisk core engine knows that there is a rule that should be fired. It pulls these pieces of code from the internal Whisk repository and instantiates them to respond to that request and then execute and return the response and then just go away. And so using this model, you've got the event triggers that come in from Cloud or any of these. These are the pre-built-in packages, but any triggers really can come in and again fire off events within an OpenWhisk system. And you know those traditional microservices, still the web-based REST ones, you can map an API service to the OpenWhisk system. So you can use, for example, a tool like API Connect within Bluemix. You can use a third-party provider like Apogee. Or you can even write your own sort of proxy that implements a REST API. And you, in turn, can call whatever trigger behind the scenes. So there's several different ways to do that. And those, in turn, will invoke. So your CRUD-based web services can then be mapped onto one or more actions, however you've designed them inside of OpenWhisk itself. OK. There's a use case that I've been working on in the IoT space to really show how OpenWhisk can come together to implement some business value for an appliance retailer, so improving their customer service. There's a video I produced for it. You can find that at the bit.ly URL in the top left. I call it OpenFridge. So in this IoT use case, a smart refrigerator that has a bunch of parts within it, such as a water filter, can emit readings about the status of that device. And it can emit those through, for example, MQTT to the Watson Internet of Things platform up on the Bluemix cloud. And those messages can be tied to OpenWhisk actions to do analytics on them and produce any series of different decision trees about what to do next. So in this example, if that refrigerator needs a new filter, you can have an action that checks to see that it is within a threshold of needing to be replaced, create an order in the database, create a report about that in the database, and another action can then go ahead and check to see if the customer is in warranty and automatically ship the part if they are, notifying them through a push notification or just an email that that part is on its way. And so how this use case is broken down into an OpenWhisk environment is that there's a package for Watson IoT that has those, on that side, has the package for the MQTT broker, that whenever there are messages that come in, they can be linked through a feed, which is the trigger mapping, to that action. So for example, here we have the analyze the reading, see if the filter life is less than 20%. If so, store it in the database for processing. The trigger of that being inserted into the database is linked by the changes trigger to a create order function. And so what that will do is look at the appliance, look up its customer, and compare the data to see if it's in warranty, and if so, automatically create the order and ship it. And if they're out of warranty, it may still create that database with a different state flag. And this, in turn, would trigger a notification that says, there's an order here. Please go approve it on your mobile device with Touch ID or something to link it to a payment system. And that same alert customer function, that action, can also be mapped to a nightly alarm trigger that basically lets somebody know that their warranty may be expiring in 2 weeks. So it notifies them there. And there's also packages for Cloud and for SendGrid to facilitate that integration so you can assemble these applications, these event-driven applications. Okay. And so to set up those actions, so OpenWhisk, the open source project, provides a CLI. On the hosted Bluemix, there's also a web IDE. But within the developer workflow of creating those actions is that they would write the JavaScript function. Here it's analyze-service-event.js, named analyze service event, and given a set of Cloud and credentials that are injected as parameters to that function. And then I can iterate on that outside of the actual messaging environment by invoking it directly with some sample code and getting the logs directly sent back to me in a asynchronous manner so that I can test that my logic works. And once I'm happy with that, what I then do is use the Whisk command line tool to subscribe a trigger to the type of messages that I'm looking for from an MQTT broker, and use those. And I link that trigger to my action by creating the rule in the final example there. So those are how the perimeters come together. OK, so let's take a look at, that's the developer perspective on OpenWhisk. So let's just take a quick look at how the open source project has basically been approached and designed. So again, it's designed in such a way that it's really extensible by offering a bunch of built-in languages, but also the hooks for creating those. So in the case of the PHP example, we had a meetup in New York City where one of the developers of OpenWhisk came in. Someone asked for if it could be extended, and he opened 2 files. He opened an invoker source code and another component with an OpenWhisk, made 2 changes, and just for the proof of concept, took a Docker image that had a PHP runtime in it, linked that in, pulled that into a repository, and he had an OpenWhisk environment that supported PHP. So it's built to be like that, and obviously with Docker, any arbitrary binary. It's been designed to already build on the whole community of excellent open source that's out there, and is licensed under Apache too. So you'll see in the light blue, most of those are already existing best-of-breed components, building blocks for cloud-native applications. So in this case, a user requesting, for example, the developer pushing code through the OpenWhisk API through those command lines. They can interact with it all at an endpoint. The triggers that come in, they also affect that REST API that the OpenWhisk runtime provides. A controller will check any sort of credentials needed. So in a multi-tenant hosted system, ensure that whoever is requesting that action, whatever trigger's calling it, has the rights to do so. And the controller will then look at its registry of actions available, the mappings, and put them on a Kafka queue. And within those boxes below are a whole bunch of Docker hosts that will take that code, inject it into a container, execute it, and return the results. So it's been designed for high performance. I don't have the latest numbers, but it's a very efficient system, very good at concurrency and responding in pretty good millisecond values. And again, it's being built on Docker there, on those Docker hosts. There can already be a pool of running containers that can be reused by the same tenant if actions come in fast enough, or otherwise help improve the performance of the system. Okay, so we are in the early days of serverless. There's still lots to be learned. There's a ton of best practices to kind of figure out how best to empower developers to create these new types of event-driven applications. But the promise is certainly there of the new cost model, the efficient cost model, as well as all of these brand new applications coming online. So with serverless, it really holds that promise of helping developers build things faster, better, and cheaper. And we're hoping that OpenWhisk develops a large ecosystem around it to support those workloads for these emerging workloads, for these event-driven applications. So we invite you to get involved. If you go to openwhisk.org, that'll take you directly to the GitHub repository. There's an OpenWhisk organization. There's an OpenWhisk project, and several different repositories, for example, for the collection of third-party packages. We've got Slack on the Developer Works Open. We've got a channel, OpenWhisk. We've seen participation from lots of interested other companies. It's been great to see those grow daily. And if you just want to get started with playing from a developer point of view, instead of worrying about the open source underlying fabric itself, if you go to bluemix.net, you log in, just look for OpenWhisk. It's probably going to be on the masthead, and that'll show you how you can start experimenting with some sample code, working with the web IDE, and also looking at the monitoring. So open source Whisk gives you the log stream that you can look in the CLI, but within the Bluemix environment, you can actually see the correlation of actions, the messages that have been emitted, and things like that. OK. So if you're interested, I'll be at the booth for the rest of the day, so stop by, and please do get involved with the project.